Hello and welcome to Rubber Deck Engineering. Tonight, we're going to play with Swift and maybe even build a fractal or two. Hi, Dr. Barth.
Hi, Eric.
It's
I am excited about Swift. I've read about it. I saw some videos where somebody played with it, but I have not written a single line of Swift ever.
Oh, really? I figured you had back when we, looked at all various languages for Flutter. Or you learned that you couldn't Swift outside of Apple platforms and moved on, or?
This was before the big Swift open source thing, so it was at that time it was really not possible to use Swift outside of Apple's world. But I mean, since then, like the Swift community has expanded dramatically, and the compilers are all open source, and it's way more accessible now.
Well, sorry, I've had a little bit of distraction. I also had very little. I think I played with the Swift playground when I've played with the Swift playground, the little thing on the iPad, and I think I did a Swift UI tutorial when Swift UI first came out. And
Swift UI looks pretty slick. Like looking at like the demo sample code and stuff, like it seemed like a really neat system. I like curious how it like plays out in practice.
Yeah, it'll be fun. So tonight we're going to start from a basic Swift UI project with a green square. I got that much running. Hello, Morse code.
We always got to start with a green square. Like,
I was trying to prove
it's like the pulse check.
draw.
Like, is this UI tool good alive? Like, can it draw a green square? Okay, and now we're good to go.
And then we're going to see if we can move on to Fractally land. We discovered in the pre-show that we may need to figure out how to draw pixels instead of paths, but we'll figure that out.
Yeah. So should we start exploring?
Yeah. Let me get our windows set up here. Okay, that is a blank code machine. I think I meant this one.
This one.
So we're in Xcode.
It's a green square. I like it.
And we have a green square. It's official Swift green too, color.green. And I actually typed out my very own these 6 lines of Swift code.
So what's going on here? So there's a text view that's on top of this square.
I think it's behind it. I think it's
Oh,
drawn.
I see.
Oh, no, maybe. Oh, I think these are just previews.
Oh,
We're not
we have a
seeing the
question.
final thing running.
We have a question in the chat here.
Okay. First,
Where's the
render
Flutter?
tree in JS.
Okay.
Now Fractals with Swift. Where's the Flutter love from the Flutter founders?
I think if you go through the back catalog of the show, you will find that we've done an enormous number of episodes in Flutter.
Yes.
But part of what we're doing here is exploring the space and learning how other UI toolkits work, how other programming languages work. I think it's a really healthy thing to do as an engineer to get exposure to these things. And then that ends up broadening your horizons, and then you sort of feed it back into the projects you're working on, and it makes them better.
I also do Flutter 7 days a week or 5 days a week at least. And so it's fun, one night a week to do something, to learn something else.
Anyway, if you're looking for a Flutter playlist, I think the Conway Game of Life playlist is pretty neat. You might want to check that one out.
Okay, so I think these are separate, like it's just showing these various like individual lines, I think.
Okay.
I don't know. I've not actually ever tried to run this.
Should we try to run it? There's a big play button.
There's a big play button. I pressed it. Automatic preview updating paused. Okay.
I see, because it's busy building. It doesn't want to update your...
14 to 20. Yeah, it was... When I first launched this, I was like, oh, the preview thing is really cool. But it is sort of cribbing over the fact that you have to do a long ahead of time compile step in order to actually get your thing running.
The hammer has said the build has succeeded.
Okay, where is it?
Something's bouncing around.
Bouncing around.
I remember when we were first working on Chrome, the goal was to get it to launch in one bounce. Because then it would go whoop, whoop, and then you'd have a browser. Turns out it's pretty hard, though.
So here's our hello world.
Oh, that's cool.
I have no idea what's... Oh, interesting.
Oh, I see.
Oh. So there is this... It's like geometry provider or something like that.
Can you resize this window? I see.
Yeah.
Okay, so the rectangle is sort of fixed, but the hello world is somehow glued to the bottom. Interesting. I wonder what.
Presumably there's like an implicit list or stack or something like that. I don't know where
Can
the
we,
text. Go ahead.
can we start at main? Like, where does this? Is this all the code there is in this app, or there's? Okay, so this is like we've declared an app. Our body has some scene, which is a group of windows, which has a content view. Okay.
And this is content view. Which
Actually,
itself is a
content view we've agreed is a view. It has a body, which is some view.
Oh, here's our previews. This is what's making this.
Oh, I see.
But why, I still don't understand why it's making two of them.
It says previews, like it's
But why
Maybe
is it
this
still splitting out?
I wonder if it's a list of some sort. Like, what happens if you put "Hello World" in here like 4 times?
You mean in the like the preview thing?
I just add to here, like.
I feel like we're approaching this like archaeologists or something. We're just like,
But that's why we talked about learning styles like a number of episodes ago. My learning style is like, what happens if you hit it like this? Does it explode? Does it? So that didn't have a big effect on our previews.
maybe the previews understand that they're automatic preview updating paused. Probably
Let's
because
resume
we're
it. Okay.
previewing in Fractal.
Oh, so it's previewing in the over here.
Okay, this
I see,
makes
so
no
it's like-
sense.
Interesting. Try changing the text to see if it's actually.
Whoa, okay. No, it made actually a second. Whoa, is it running twice? Yeah, it's running
I see.
twice.
I see. So we built one that was like a production one, and then it was like, hold my beer. I want to build a. I want to build you a live one that does live updating.
Huh.
So how live
Okay.
is it? Like, if you change some of this text, will it just like? Okay, that's
Okay.
pretty sweet.
Yeah. That would. I mean, we could even do fancier things. Like if that's true, then we could do things like this, right? Tile left. Put this right. I have no idea if this is like valid or not, but all right. I wonder if it works for other things. I mean, I just saved it. I didn't have to do anything. At least that
Try
first
focus.
one.
Try focusing the other window. Yeah, so maybe on like compile on blur or something.
Okay.
That's neat.
Okay.
So I think we talked about. Should we try to make an image and try to because if we want to do a fractal, we probably want to make an image of some sort.
Okay, so that we're gonna have to probably go to the internets because you and I.
Right. I found this thing that was. Super Declarative is
thing.
trying to help us.
Oh, almost look like one preview of at some predefined resolution and one previewed at a min geometry.
Oh, okay, that makes sense.
Okay.
That's something we never actually did in Flutter, which is we only ever like previewed it at the resolution it was running at. We didn't give you like here's an 8-up display of what horrible things resizing the window could do to your UI.
It's so wild that like there's 2 copies running.
Well, I think you just quit that one. Like that's the prod one that you built. I think you're clearly supposed to do it in this interactive mode.
I'm not sure. Like it didn't have a separate thingy on here, but okay. Anyways. Okay. There just feel like there's a lot of ways to preview the same thing in SwiftUI. Okay, but we were working on this.
Right. So we found this thing that was UI. Yeah, that thing.
With a bunch of smileys.
Are they smiling or are they crying? I can't tell.
Or they're like lying down? I don't know. Like what is that? A fence?
I think this is like in Ren. They look like sad faces. They do. I think this is in Ren. Like remember when you declaring your prototypes in Ren, you put these like underbar comma space underbar comma or whatever the syntax was. I was like, here's how many arguments it takes. I wonder if this is some sort of like internal representation of what this symbol is like.
Okay, this is the like actual symbol name or whatever.
Yeah.
Yeah, because that's what ren would do, right? It would except the colons would be commas. I don't understand what this one means.
I think we should try it. So, like, my theory is that this will give us a thing that will let us draw, and then we'll be able to grab the image out from inside of it.
Till the stack overflows. Accept all the cookies.
Delicious
Nom, nom,
cookies.
nom, 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 nom. Okay. Whoa.
Whoa there.
Yeah. Whoa there. We're in Objective C land.
Is that small talk argument syntax? Yeah, something like that.
Is this this is not a C function, is it? I mean, it looks like it was at one point.
Oh, I think we're looking at the Swift documentation, but I don't know if it's like a Swift thing that's been hallucinated out of an Objective-C thing. They have all these like layers to their system.
Okay.
I think we just try it. Like, what happens if we...
Let's try it. Okay. So... Whoa, I don't know what happened. Oh, I think once I pasted something, it then quit the little preview app that was running? I don't know. Okay. Tell me what this is missing here. Expected size,
CG.
bool, and scale. Okay, CG
The
size.
scale.
This used to be like CG make size or CG size. I actually did work at Apple many years ago, like almost 20 years ago now.
I think it's going to be CG size make.
Size make. 200.
Something like that.
Floats. And then this is a
then-
bool of opaque, and we'll say true. And then what was the third expression?
The scale, which I guess...
Scale 1.0, sure.
Yeah. Then we probably
Okay.
need to capture the...
Is this then, do we, closure this sucker?
I think you want to take it outside of your view, like up there where it says var body. Like, I'm not sure if we're in, like, write some code. Or maybe we should write a function that's going to return our image.
Okay. That could make sense. So that's like func make fractal.
Yeah.
I don't know what the caps here make.
I think the camels are strong.
More camels? Okay. And then this is going to be... It's going to end up returning like a CG image or something like that?
Oh no, the camels are weak. Their heads are down.
Okay. And what... how do you indicate a return type?
It may just be implied.
Oh.
Oh, arrow. You put an arrow after your... Yeah, there.
So it's rusty.
Yeah. This is like the modern cool kids way of doing types.
All right. I like it. Okay, so... Yes, our learning style. I see all these things about how you need to learn Dart before you learn Flutter. No.
We didn't learn Dart before we created Flutter.
That's true. Okay.
Your very first Rust program was a Ren virtual machine. Seems to have worked out.
We did the Ethereum virtual machine first.
That's true. We did warm up with a smaller virtual machine. For the record, Eric wanted to make a UI toolkit in Swift, and I talked him down to a fractal drawer.
Okay, so
I think
we theoretically call this...
I think you want to capture this in a variable, which I think you do with var.
Var foo. Oh, that's not foo. Foo. Yeah?
Okay, and then...
No semicolons. It still doesn't like me. I don't know what it... Cannot find UI begin... What is this thing? It's a function in UIKit.
This thing doesn't return anything. Like, how do you interact with it?
presumably it changes the main context. So what?
Whoa! It like mutates some global state.
So this is deep. Again, this is maybe wrong because it's been 20 years since I've worked on this stuff. But it used to be that at the CG layer, it was the C API and everything was explicit, and at the NS layer, there were like the NS graphics context, main context or whatever, got mutated by all the stuff. So it was implicit what you were working with.
Yeah, I think doing a Swifty UI toolkit would be cool. Like, I mean, clearly Swift UI is the main one, right? But it might be fun to play around with.
Really, what we're trying to do is we're trying to get to pixels.
Right. So this makes sense. So then, if this thing's really operating on some global static state, then I think the next thing you want to call is UI graphics get current context, which will give you a CG context to play around with. It's totally wild to me that this is mutating global shared state.
So we still don't. We need to import another.
Maybe to import UIKit. This stuff is from UIKit.
Well, but we want to be working on. Is UIKit exist on the Mac? Because we're building a Mac application.
Oh. Swift doesn't pave that over for you, like you have to do it in Hurts?
Well, UIKit, it was last I knew was an iOS only thing. I apologize in advance for the train wreck it will be this episode.
This is just how we begin. So then, is it NS?
It could totally be NS. Okay, Swift UI pixels. Get image for current context Swift. Yeah. So, like this says iOS Catalyst 13 plus. Well, that's what we're in.
Okay.
So maybe I
think you just try importing UIKit. I think they're merging all their stuff together.
Yeah, that was my thought too. Oh, never mind. I'm only on Big Sur.
Oh.
Oh, today I learned. I guess maybe I don't have a fancy enough computer. Maybe Catalyst isn't out? Okay. So we may be in Sad Panda land.
We can do things with paths. We can do like the Sierpinski gasket.
Let's try that. I think to like salvage our episode, and maybe I'll figure out how the hell I'm two major OS revisions behind on this laptop. So talk to me about Sierpinski gasket, whatever that is.
Okay, so let's draw a triangle.
Okay. There, I drew a triangle.
Okay.
Let's resume.
So what you basically want to do, that's great. So you want to create a function, so we don't want to fill it, we want to stroke it.
Not a problem. This part I can do. Okay?
Okay. And then what you want to do is you want to, I think you want to close triangle.
Yeah, path.close. I don't know what that does, but sure.
So basically what you want to do is you want to turn that into a function,
Mm-hmm.
and then you want to recursively call the function, because you're going to recursively break your things up into little tiny triangles.
Okay.
So yeah, imagine that you get called with the points of a triangle,
Mm-hmm.
and then what you're going to do is you're going to subdivide that triangle into, let's say, 4 pieces, 4 subtriangles, and then you're going to draw into 3 of them, but not the middle one. And then you're going to bottom out when you get too small.
It's like 1, 2, 3. I could do like an array or something, but I don't know how to do that. Okay.
So we have some more comments. Last week was a fun train wreck too. Yeah, I mean, this is kind of what the show's about. Like, you've come to the right place if you're looking for a train wreck.
Looks like good language for functional branch programming.
Yeah, I think we might have been mixing the streams between UIKit and Swift UI. Like we We may need to research how to actually get an image that we can draw into.
Yeah, I mean, I haven't professionally written for the Mac in a very, very long time. Okay.
That should have cross-platform. Yeah, we cross through the looking glass, as it were.
Okay, so we're doing this thing, and then we're returning a path from this, presumably?
Yeah, so you want to draw that triangle. Yes, I don't know if you want to... I think you want to try to make one giant path out of the whole thing. Otherwise, you're going to end up with like a bajillion paths.
Okay. We're just going to make a giant snake game kind of path here.
Yeah.
So, 1... Oh, what are you yelling at me about? 2, 3. Result of call. So you think that this... Whoa. Interesting. So I may need to put a path in here?
I think you want to pass in a path. You want to move it all around, and then return. And then the thing on the outside should dump that into a path view, or whatever this thing is here, and then struck it at the end.
Okay.
I think closed subpath is going to get you in trouble. I think you want to explicitly move to 1 again.
I want to add line 2.
Yeah.
Okay.
Now I think you want to recursively...
Can I use mutating on an immutable? What do I do? Type mut? Like, what's mutable?
Oh, I don't know. That's a good question. Mutable parameter.
Oh, I learned. I don't know if a Flutter
In
is
out.
coding it. Oh, what did I do? Oh. In out?
In out, yeah.
Is it like one word?
Yep. It's like IDL style. Yeah. No squares. Yeah, just like that.
Whoa, I like how they animate out. That was nice.
It's beautiful. Like that's what I love developing on the Mac. It's like even the developer tools just had these beautiful touches to them.
Okay, why are we upset at life here? Cannot convert value Cgpoint to... Well, that's
you need to
because
pass the path. Yeah.
So I learned in prepping for this show, the first thing I tried was I tried to make a project called Swift. And then Swift... Xcode let me do it. But Swift got mad at me. It was like, nah, you cannot be Swift unless you are part of the Swift standard library. I was like,
So,
what?
we are Swift. You are not Swift. You are slow. It's still mad at you. It's got two doorknobs.
2 doorknobs, stop signs, missing argument labels. Oh, I have to have labels? Okay.
Okay.
Pat. Oh, does that one need one if it's the same name?
Oh, I don't know.
2.
Actually, something I missed in Rust is that they don't have name parameters, which is something I just started using a ton in Dart.
Okay. Path. I've gotten used to in Rust where initializers, if the variable name happens to be the same, they let you elide the label.
That's also really nice. Yeah, I found that frustrating in JavaScript. All these like shorthands that Dart has for like assigning to this and everything.
Mm-hmm.
I really missed them when they were gone.
Aha. Insert. Fix it. Yes. Okay. That's very reminiscent of C++, but the Rust in me is like, oh my god, I'm passing an immutable thing. That's not cool. I'm borrowing it. Okay, so this works.
So you basically had to mark the fact that this was an in-out parameter at the call site so that you weren't surprised.
Makes sense.
Which makes sense. Yeah.
Okay, so now we need to subdivide this triangle until we can't subdivide anymore.
Yeah, so you want to basically call yourself recursively, but you need to invent some new points. So you want to bisect each of the edges.
Mm-hmm.
So let's try to do the first one first. So compute a point that's halfway between 2 and 3.
I suspect there's some amount of point math here.
Yeah, but you just like try just adding them and dividing them and see what happens. You may need parentheses.
Referencing operator on vector.
Yeah, let's see. Midpoint.
On vector math. We had these sort of function overrides in WebKit, I remember. Cgpoint math.
Yeah, like can you lerp? Can you lerp two of them?
Yeah, okay, that would be cool. Yeah, here's Cgpoint operator. Do not do this at home.
Oh, they don't define the operator for you?
Well, these are C structs, I bet. Oh, no, they aren't. They're probably Swift structs, whatever that means.
Try just adding. Can you add it together and get the compiler to tell you what type you have? That seems happy. There's no like red doorknob. Oh no. Oh, sad face. Okay, we'll just call make point, I guess.
That's a little lame. Like, I would kind of expect... It's a structure. Init. X applying debug description equal to animatable data. I don't know what that does.
Yeah, it says, I found here an official forum post that says, there isn't operator overloading for Cgpoint, but you can write it, which is terrifying.
Okay. So you're saying I need Cgpoint make, or is it just Cgpoint this way?
I think just Cgpoint that way is fine. That's what you did below, so.
Oh, I did? Oh, I see. I did it with that. Cgpoint x is 1.x plus 2.x divided by 2. And you're right that I may need some. Okay. I keep expecting it to yell at me about that being an integer type. This is, okay, so this is, needs to be a function.
That needs to be a function, yeah.
Yeah. Midpoint. A, Cgpoint, B, Cgpoint. Okay. Oh no, it's going to make me type those again, isn't it?
Can you align them? Like what happens if you just say Cgpoint with no... Oh, but then you don't have a name for them. Can you really not do anonymous arguments in Swift?
Maybe that's what that little underbar means?
Oh, I see.
Okay. Super Declarative asks, random Swift question. What's the meaningful difference between classes and structs in Swift? Okay, someone watching this must know the answer to that. I don't.
You're watching us write our literal first language, so...
Although, come back in a month or two and we'll be experts. Because we'll have written not the Wren compiler this time. I'm not an expert in Rust, but I feel pretty comfortable in Rust these days. Okay, did you decide that you can't do anonymous?
I haven't found an example of it yet.
A.y plus b.y. Okay. Midpoint. Why is
if you don't want an argument label for a parameter, write an underscore instead of an explicit argument label. So if you add an extra underscore, like before the A and then put a space, that turns this feature off.
Okay, I like that.
It's a little bit goofy.
That's very goofy.
It's like in Rust how they decided that const was the default, and mutable you had to write everywhere.
They're saying mutt everywhere.
You had to write mutt everywhere.
Yeah.
You're 15 minutes further into Swift than I am. Well, that's why we invite you to come on this journey with us.
Midpoint 1, 2. All right, so I'm getting here. I'm doing it. So I'm a little skeptical that we're doing this recursion on the stack, but we'll survive.
And we could try it this way for a while, and then you probably want to put in like a depth argument so that we know when to bottom out. Oh, I think you need to add a return value to your on line 16 to your midpoint function, a return type.
One of the other quirks of Objective-C, which is burned into my brain because I worked in so much Objective-C while I was at Apple, is that although you can return structs from Objective-C calls, it is dangerous because if you ever call Objective-C on null, it will zero the first, whatever it is, 4 bytes.
Just leave the rest of your structure
And
random
leave
garbage.
the rest.
I think this is why they went to Swift, because they're like, Objective-C is cool, but it's got some really wacko things in it.
Well, it's just this very thin layer over C. At least the original Objective-C was. It was just a precompiler. Missing argument labels. Well, that's because I don't want them.
Yeah, why don't you take them away? Yeah. So you're calling yourself. You want to call yourself recursively 3 times, and you don't want to always pass the midpoints. You want to pass like one of your original points and then the other midpoints.
Okay. So which one?
Well, you just want to do all 3. It doesn't really matter.
So like I want this to be 1.
Yeah.
And then this to be 2, or like what? I don't. Because my midpoints are all different, right? I don't need to recalculate them every time.
Right.
So this actually maybe should be A, B, C, A, B, C, A, and then this can be, what is it, var or let? Var AB is equal to midpoint AB. Var BC is equal to midpoint B.
I feel like we're in like a high school geometry class, like AB with a little bar over it, like.
Totally. Except this is going to be much prettier than high school geometry class. Which they should just do in Swift playgrounds these days anyways.
I would do CA out of like total.
Yeah, that's what I meant. CA. Uh-huh.
Okay.
Okay.
Yeah, then you want to make triangle. Let's try A, and then BC, CA.
Okay.
Then I would try AB, B, and CA. Yeah. And then I really think you need a depth parameter to terminate your recursion.
Well, we also just, I mean, we could calculate distances here.
I think we just start simple. It's mad about something.
Can
Oh,
I-
you need your ampersand for your path.
for our path. Okay, fine. Starting simple with a depth parameter. Depth int. I have no idea what. Like uint.
Sure. I think it's
Unsigned.
uint.
Looks like uint.
I think
Is,
Yeah, you like that. I think capital U, capital I.
what's the T versus S? One's a struct.
Oh, maybe it's like boxed and unboxed. Let's see. Swift unsigned. Sure.
I just don't
It
know.
always annoys me languages that have the boxed and unboxed. Oh, unsigned integer is a protocol. Definitely not what we want. We want the primitive. You want capital U, capital I.
Okay, done.
Yep, that's the built-in data type. If you spell it out, like the words, then that's the protocol. Just like the thing with a v table or something.
Okay, and then this is going to be depth 0. Okay, and then this is going to be, whoa, what happened? Oh, here. If depth is greater than 5, return.
Okay.
I have no idea what that is. That return path?
We're just mutating the path, so we don't need to return it.
Okay. Can I convert?
What does it matter about?
Oh, I'm path has not been.
Oh.
AB was never mutated?
Consider changing it. Can the triangle just fix it? Does it consider something? Oh.
Whoa. I see.
Okay.
Var is like the mutt version?
Or, yeah, it's variable, I guess, and let is like the
Okay.
non.
And let is like const?
Okay.
Alright, I hear you. That's reasonable. Okay. Where's my amazing preview?
Resume.
I fear this is not going to be... Well, yeah, this is not going to be like Rust, where like if it compiles, it works.
This is a cool picture. I think our midpoint calculations are off because we're flying outside our original triangle here. Oh, we have a hint. Oh, you need to divide by 2. Missing the old divide by 2.
Oh, yes.
Thanks, Nick. That's saved us a ton of time.
Yes, I agree.
More parentheses.
Oh, I see. We were just like going to infinity with the Y's here. Oh.
More parentheses.
Oh, yes. More parentheses. Okay.
All right. It's something. Can we embiggen it? Like, make the whole thing bigger to start with. Just like change your. No, I don't mean like that. I meant change your like initial constants to be like 0 and 300 or something.
You mean like these?
Yeah.
Well, yeah. So like this could be 0.
It's like octal 0.
Okay, so this could be 0, and Y could be 0, right? And this is 0. You're right. It is octal 0.
It's a cool picture. It looks all twisted.
Why is this not like auto formatting all nice? I bet that doesn't work. I wanted to format 1 per line.
I love the octal 0. That's hilarious. Okay, why don't we try to only recurse once? Like take out some of our recursions to figure out why. No, I mean only call ourselves one time so we can see like what's happening as it's drilling down.
Oh, I see.
Yeah. So that's the wrong midpoint. We need the we don't want the we don't want the BC midpoint. We want the AB midpoint because we got to put the midpoints that are close to the original point.
Ah, so they both should have. So this should AB. And shouldn't they just be the first?
Yeah. Sure.
AB, and this is BC. And this is then
Do you know
C.
what the Sierpinski gasket looks like? We could have pulled up like a legit version of it.
That'd be cheating. This way we can play telephone. But yes, no, we could. Okay, that looks more legit.
It looks more legit.
Sierpinski gasket. That's still not
okay.
right, though.
The first level was good. No. Huh. What, can you make it 1? Like depth greater than 1?
Well, 1 looked correct.
One look correct. Okay. 2 is all
I
messed up.
suspect it's our parameter ordering here.
Okay. Yeah. Okay, so we need to play around with the parameter ordering. Maybe like we need to keep like a clockwise, like keep it in clockwise order or something.
Huh.
I assume move to like jumps up and moves, right?
Correct. Move does not drag a line with it.
Okay.
Oops.
So let's think about this. So we went from so A was in the 0 0.
Mm-hmm.
B was down,
Mm-hmm.
and then C was across. So that's in counterclockwise order. So let's try to keep the counterclockwise order going.
This is down, yes, and then over. Okay?
So A to B, then over to AC, and then back to A. That also looks counterclockwise.
I wish I could better understand which one of these it is. Like, I don't even understand what I'm...
Yeah, I would expect it only to have drawn one more triangle, right? Because we called ourselves recursively once. Like how did... Like, I just don't understand how it drew this crazy thing. Can we try reloading it? Like, did it...
What's this? Whoa, I don't know what I pressed. Oh, it's previewing in Fractal. Now it has 2 copies of it running again. Maybe if extra lines it connects the last point of recursion with the first and the next line. Yeah. I could imagine it doing that. So, why did you think that closed subpaths was gonna make it sad panda before?
Oh, we can try that.
I don't know what it's doing here now. Because I quit the thing. Whoa. What's this?
There's a scroll bar at the bottom.
That didn't help. I wish like every layer was a different color or something.
Oh, could we... Oh, no, because we picked the color at the end.
Yeah, we'd have to like make each layer a different path.
Can we debug? Like, can we set a breakpoint in here and hit it?
Sure, I would think so. Okay. Build succeeded.
The hammer has declared the build has succeeded.
I remember when macOS added those like global notifications.
They're beautiful. Like, it's a beautiful hammer. I'm not going to miss it.
Come to me, Fractal.
We're in the breakpoint now.
Oh, okay.
Okay, so this is our first level. So, can we see what our variables are?
I think they're right down here.
Okay, those look like sensible numbers.
I don't know how to change this. Oh, there we go. Okay. I bet there's a continue button here somewhere. Okay.
Okay, so now we're one level deeper in the recursion. Oh, 0 0 0 0. That looks no good.
Oh well, it's just we haven't
Oh, I see. We haven't computed
done those
it
yet,
Okay.
right? So if we went to here.
Yep. Okay, so let's think about this. This is where we're going to get messed up. So, so A is still 0 0. That looks good. And then the thing we call next is going to be AB, which is 0.75.
Mm-hmm.
That looks totally sensible. Then the next thing is going to be CA, which is 75.75. That sounds totally sensible.
I wish we could like see it as it was drawing.
Can we? Oh, I see. Because it won't draw till the end. Well, keep going. So then I expect it to.
We could do this, right? We could do if depth, right? But go ahead.
Okay, so that's only drawing depth 1.
I mean, we're still stopped in our thingy, so we'd have to.
That looks good. That was what I was expecting. I wonder if the preview was just messed up.
That's possible. Well, is that this code that I changed?
Well, yeah, take out those,
okay.
that check. Maybe should we pass down the recursion? Oh, we are. We're passing it down as the first parameter through the recursion tree.
You're right. Here we go. This looks correct.
Okay. So now what happens if you turn on the second one? That looks correct.
Mm-hmm. This sounds like a hot reload bug kind of thing.
Yeah, like it got...
Like it had some bad state. That all looks great.
This doesn't quite seem right. Like we're only
this
going
sort of
into...
like rotate, isn't it?
Well, like we only drew... I just don't trust this preview. Like the... Oh wait, go back? Maybe the error is telling us something useful. BC is never used. No, it is.
I think it's just confused.
Try running it for real instead of using the preview. Because we're clearly, in the first level, we're clearly drawing 3 triangles.
Place?
But in the second level, we're only drawing 1 triangle in each of them. Yeah, there we go. There you go. Sierpinski gasket. There's something wrong with the preview. I don't know why the preview is like not working.
This is
That's
why
really
people
funny.
don't trust these things.
Yeah, yeah. Can we look at our beautiful gasket a little bit more?
Yeah.
It's great. I mean, it's usually drawn as a equilateral triangle. Maybe can we adjust point A to make it equilateral triangle, and then we get like the one from the textbook.
Point A to make it. Oh, okay, sure.
Yeah, just like move to 150.
Is it 150? 150.
There you go. Oh, now the preview's showing the right thing.
And it even animated there.
Yeah, maybe that's what it's trying to do. Maybe it's trying to like animate or something. Like it's being too fancy.
I don't understand which ones preview what when. I actually kind of liked ours better before it did this.
Oh, the
totally
right triangle.
It's totally Zelda here.
Well, I think this is where they got the idea.
I wonder how to make this. Like, is that anti-aliased? Oh, you know what? It's just that my monitor's set to like hyper low resolution.
It looks great on the stream. Like, Eric is using a actual monitor, but we've scaled down the pixels so that it's actually viewable on the stream. And so for him, it looks like totally banana pants crazy.
We couldn't figure out how to actually zoom on the Mac. But anyways, well, this is good. We wrote.
We wrote both lines of code, but we achieved our goal. Right, our goal was to create a fractal in Swift, having never touched the language before, and I feel like I learned something.
I totally learned something. I mean, I am far from a Swift expert. Here, I'm going to put you on screen so I can see you. But
this is how you start. I mean, I don't know. I find like I've read a lot about Swift, but like it's so different to actually like write it and like participate in the process of going through it. That, I don't know. I just learn it in a different way.
I think, as one of our viewers suggested, I think it'd be fun to build like a rendering tree in Swift. I just think we need to tech up our Swift a little bit to be able to accomplish that. Since we can't even figure out how to get a canvas.
Somewhere in there's a canvas that we'll be able to get to. A CG context UI image rect something.
So, since we have a little time, did you learn anything this week you wish to share?
What did I learn this week? Oh, I was trying to we're looking at system updates in Fuchsia, and we're wrestling with the problem of what if the device has been like in a drawer for a long time, and then you turn it on, and its clock battery is dead, and so it wakes up thinking it's like 1970, and then it wants to update. So it contacts the update server, and the update server is like, here's your update, and here's the certificate from like 2021. And your device is like, but it's 1970. What's going on with your 2021 certificate, my friend?
Isn't this what the time D is for?
Yeah, so then you get a really interesting question. It's like, should we wait block the update until the time service like connects to the network and establishes a synchronized time, like a valid time value? But then, like, what if that makes updates not work? And then, anyway, it gets complicated. Oh, we have a comment here. If you want to try that per pixel fractal thing with Flutter, implement a per pixel painting in Flutter processing. Oh, neat. Yeah, I know exactly how to do it in Flutter. Like,
oh yeah,
just like jam the custom paint widget and go to town. Like, anyway, yeah, so we're still struggling with this because, so
the custom paint widget.
In Fuchsia, like when it wakes up, it won't actually think it's 1970, because when we build an image, we remember in the image like when we built it, and then we say, it's never going to be 1970. If you ever forget what time it is, like, please at least assume that it's 2000, whatever it is, August 26th, 2021.
That's slick.
Yeah, I mean it has this funny property that it works better when the device is like newer and up to date. And in the case where you've pulled it out of the drawer after a couple years, it's still not 1970, but it's still pretty far off from the actual time. Anyway, that's the kind of problem that we were wrestling with. I don't think we have a solution yet, but that's the problem space we're working in.
A couple questions asking for the next episode on Fuchsia, which we may do to return to at some point. And William suggests, always loved HTTPSY, not something I'm familiar with, for allowing the client to specify which certificate to use. Is that for like the time update problem, perhaps?
Well, it just allows pinning. So normally to validate a certificate, you have to have like a chain up to a root that you've paid for or whatever. But like if you know ahead of time what certificate it's going to use, then you can give it to the client, and then you don't have any of these problems. You have other problems, but you don't have these problems. I don't know, Eric. What did you learn this week?
Well, I learned the computing stuff that I learned. I learned a bunch of managing stuff, but that's not really for this podcast. But the computing stuff I learned was all about fuzzing, and I fuzzed some program that was not mine, and I fell over terribly. But I learned a lot about fuzzing in the process. In non-computing, because I was on vacation in Austria last week, or 2 weeks ago now, a week ago, I'm finally over the jet lag. I learned a lot about bread because when I lived there, again 20 years ago, I was all the time ate a very different bread than we eat in the States here. We ate a very dense rye bread. But now that I have, maybe I said this on the podcast last week. Anyways, now that I have like a better understanding of bread, I can look at it, and I'm on a quest to replicate it.
You can like see inside the bread and like understand how it's made and
totally
reverse engineer the recipe.
Maybe not Neo in the Matrix, but it just makes so much more sense. And so I have like 4 different types of flour on order, and I'm waiting for all the pieces to assemble, and then I'm on my quest. A baking stream coming soon.
On a very special episode of Rubber Duck Engineering, we will engineer bread. The ultimate programming language.
You could do your pizza and I could do my bread, and we'd have it all done. Anyways, fantastic to see you. It was fun to play with Swift. We'll have to cook up something bigger with Swift when we tech up our skills a little bit.
Yeah, sounds great. See you next week.
So, good night all.